Question number 2 is easier than question number 1. Yeah. So question number 2, NFAs. Number 1, the language W, L equals W such that the first symbol in W is 0 and the third symbol in W is 1. So this is straightforward for an NFA. So just all what we need is the first symbol is 0 and the second symbol can be anything. So it can be either 0 or 1. And the third symbol is 1. And then after that, you can have anything. And of course, the accept state is this. Okay. So this is straightforward. Any questions on this? Okay. So the second one, number 2, L equals W such that W ends with a different symbol than the symbol that it starts with. Than the symbol that, so it's, yeah. So what's the idea here? It ends with a different symbol than the symbol that it starts with. What's the idea?
Branching.
Yeah, we have two possibilities. Either start with 0, end with 1, or start with 1, end with 0. So that's all what we need. So either start with 0 and end with 1, and this is an accept state, and then between the 0 and the 1, we can have anything. And then start with 1 and end with 0, and between them we can have anything. Okay? So the second one is also straightforward. Third one, W such that W, or the sum of symbols, in W is less than 4. Okay, so what's the idea? We sum the symbols. What does this mean?
Those 3 ones.
Summing the symbols. So what will drive the transition? 1. Yeah, the 1 will transition to the next state, and the 0 will keep you in the same state because it doesn't add anything to the sum. So 1 will take you to the next state, and we need less than 4 ones. So the number of ones should be what? Should be 3. And after 3, it's anything. If you get anything after that, if you get a 1, zero is fine. So should these be accept states or non-accept? They're all accept states. Now, do we need a trap state for the 1? Do we need it? No, we don't need it in an NFA. So in an NFA, you don't need a trap state, an explicit trap state. You can add it if you like. You can add this if you like, but this will be redundant, in fact, in a DFA, in an NFA. In a DFA, you have to explicitly specify all transitions, but in an NFA, this is not needed. Okay. Number 4. It's less than. Number 4 is the last one. Oh, this is going to be a lengthy one. Okay. So let me clean this up. Number 4,
It took me forever to figure that one out.
W such that W contains the substring 101 or and, not or,
1 can come before 101.
and the substring 1, 1. So the OR in NFAs is easy. You branch two different NFAs. So the OR is easy. The AND, how do we handle the AND in this case? In fact, the AND, there is no general rule for the AND. It just depends on what we are ANDing. So here we are ANDing two languages that contain substrates. So how do we handle this? The idea, yes?
I did a branch where 1 starts with the 101 substring and then has to have the 1 and then opposite way in another branch.
Okay, not,
Like,
it doesn't start with
well,
101.
like
It's not
it
starting
shows
with
up,
101.
shows up first is what I mean.
Okay, yeah, in which the 101 appears before the 11,
Yeah. And then
and another one in which the 11 appears before the 101. Is that all? So we need two branches at least. One for the, okay, let's do these two branches and think about what is missing. Does this cover all the strings that satisfy this? So the first branch is starting with, well, having 101 followed by 11. So what do I need to add to this?
oops.
Epsilon, well, to this, I don't need an epsilon here. What do I need to add to this in order to make it correct?
Loops in front of the 101.
Yeah, loops before and after. So this is substring, so I need the 01, 01, and oh, I have a redundant. So 101, 11. Okay. What should I put here?
Another loop.
Another loop. Yes. So this is where 101 comes before 11, and I need another one where 11 appears before 101. Okay, and I need 01 and 01. Okay. Anything else? Does this look right? Yes.
Are there, do the two substring need to be independent? Like, can, in the second substring, 11, can it be a part of 101? Like, for instance, can it be 1101?
Yeah, what do you think? Yeah, we should
Yeah.
cover that case as well. Yeah. So, contains these two substrings. It doesn't mean that they have to be two separate occurrences. They can overlap. So you should cover that. One key idea here is that you should cover all overlaps. And how can a 101 overlap with 11? There are two possible overlaps. This is one overlap. And there is another overlap.
110.
Yeah, 1101. So you have to cover the overlaps as well. So this is a key idea. So in the overlap, you get anything 01, 1, 0, 11, 1011. Now should I put a loop here?
No.
No. This is an overlap. So this is going to be a substring, a complete substring. Now here I put a loop, and there is a loop here. Okay? And same thing. 1, 0, 1. Okay. Okay, let's check this. Am I missing anything here? Okay, yeah, I have the accept states. I don't think I'm missing anything. But, learn the idea here. So learn the idea. And in some cases, when there is an and of, this type of language where it's containing a substring, so you should take into account two cases when the first substring appears before the other substring and the other order in which they appear, 1, appearing before 101, and you should take into account the overlap. Okay, so how many people got this right?
Mine doesn't look like that.
How many people remember to account for the overlap? So what was the problem then?
I didn't
So-
think to make it have 4 branching paths.
Hmm?
I didn't think to make it have 4 total branching paths. I tried to just focus down on the 2.
Yeah, but how can you, I don't see how you can do it in 2.
Yeah, then I clearly
Yeah,
did it wrong.
I'd have jumped.
I used an epsilon transition.
Epsilon transition for
Yeah.
what?
So I did a transition.
Okay, so let's if you would like to discuss your solution, let's
Oh.
discuss it in office hours. Because we'd like to cover as many questions as possible. But this is, just learn the idea here. And yeah, now given this, given that we have done this in class, if I give you a question that is similar to this in the test, it's going to be considered easy. So if I give you a question with 2 different substrings in the test, and I have shown you how to do this, then this will be considered an easy question. After seeing this, it should be easy. So now let's switch to, question 3 is the formal description. I think the formal description here is straightforward. So, the formal description, so you just, it's, the formal description is Q sigma delta Q0 and F. So this is a tuple, not a set. And then you specify what the Q's are for your NFA or DFA. Sigma is given. I will get to delta. Q0, you specify what the start state is. And F is a set of accept states. So make sure that even if there is only a single accept state, you do it as a set, because there is a set of accept states. And another thing, and we did this in class, so that when you give the delta transitions, so you can just give them one at a time. So delta of Q0 and 1 equals Q2 or whatever. Delta of Q0 and 0 is Q3. So you just specify all the transitions here for any given NFA or DFA. You can also put it in a table. So it will also be acceptable to put the delta transitions in a table. So you can either give them one by one, or you can put them in a table. But make sure that when you do it for a DFA, so this is a DFA, for an NFA, the transition always gives a what?
Set.
A set. So this is going to be a set for an NFA. Remember. Because even if it has one state in it, it will still be a set that has one state in it. Okay, so now let's switch to regular expressions. I still have space here. Question number 4, regular expressions. Language is W such that W consists of an even number of A's followed, of course sigma here is AB, followed by an odd number of B's. Even number of A's followed by an odd number of B's. And this is just, we did this. So even number of A's is this. A pair of A's repeated as many times as we want, including 0 times, followed by an odd number of B's. This is an odd number of B's. Okay? Now, this is consists of, so it's, this is exclusive. So this is all what the string can have. But if we change this to contains, what if we change this to contains?
Then you do this and start with.
Yeah, exactly. So if we change it to contains, this means that this pattern is part of the string. The string contains this, and it's not all what the string consists of. So when we use the consists of, that's exclusive. That's all what the string has. When we use contains, then the string may have other things. So in this case, we just put sigma star, sigma star. So this, before this we can have anything, and after this we can have anything. Okay, 2. The language L, W such that the length of W is a multiple of 3. Or W contains exactly 3 A's. So now there is an OR, so we can use the union. By the way, in some books, the notation for regular expressions, they use this OR instead of the union. So be aware of this. If you see it in another book, some books use the union, some books use the this OR, the logical OR. So both are used. So if you see a regular expression with an OR, you know that this is the same as the union in our notation.
Will you accept us using either one?
It's what?
Will you accept us using in either one?
Yeah, that's fine. We try to use what we, using the OR is not going to make it easier for you, right? It's just one symbol. So let's stick to one symbol and use it as our convention. But if you see the OR in another book or in another class notes, then it's, you know what that means. So we do each one. Length is a multiple of 3. So length is a multiple of 3 is what?
So 3 segments.
Yeah, 3 segments repeated as many times as you. So this is the length is a multiple of 3. Or contains exactly 3 A's. Now exactly 3 A's, so you have 1A, 2A, 3 A's, and then?
B stars in between.
Yeah, exactly. B stars before and in between. Before, after, and in between. B stars everywhere. So it contains exactly 3 A's. And then you have, not sigma star, but B star, B star, B star, B star. Now what will the language become if I change it to sigma star? If I change the B star, if I do this sigma star A, sigma star A, sigma star A, sigma star. What's this language?
At least
At
it contains at
least
least
3
3.
At least, yeah. Becomes at least 3 A's. So this is exactly 3 A's. This is at least 3 A's. Okay, number 3, okay, W such that W starts with a prefix AA and ends with the suffix AB. Okay, so in principle this is straightforward. We start with AA and end with AB, and between them we can have anything, so that's a sigma star. Is that all?
Yeah.
No, that's not all. I can give you a string that is not covered by this. How about this?
That does not work with overlap.
Yeah, so you have to specify the overlap. Is this string generated by this regular expression? Does this regular expression generate this string? No, it doesn't. This regular expression does not generate this string. So this is a string that belongs to the language, and this regular expression does not generate it. This does not match this. This tells you that I have to have 2 A's and A and B. So this is basically saying they cannot overlap. So you should also specify the overlap. And here, how many possible overlaps do we have? There is AAB. Oh. So how many people accounted for the overlap here? Okay, 2 people. Good. Okay, yes.
I have a question on the first one that you did. Like,
Which one? This?
yeah, on question 4. If it says that an even number of A's, but isn't it possible that that accounts for like no A's at all in the beginning?
It does, yeah. So you can have no A's.
But you have to have an even number of A's?
Yeah,
So you
so
would have to have AA.
0 A's is an even number of A's.
Oh.
So remember that 0 is an even number. 0 is an even number. Okay, yes.
I was wondering how that was a solution, because if sigma star was 1A, wouldn't that change it so it would be an odd number of A's?
It contains. Yeah. So just find in it somewhere an even number of A's followed by an odd number of B's. As long as you can find in that string
Okay.
an even number of A's followed by an odd number of B's, then it belongs to the language. So, yeah, in order for a string to belong to a language, so you should act like an advocate for the string. This string is trying to belong to that language, and you are trying to to justify that membership of that string. As long as you, within the description of the language, as long as you can argue that the string satisfies the property of that language, then that string does belong to the language. And even is a 0 is an even number. Okay, so let's switch to the next. Okay, so this is a. Okay, questions? Any question? Okay, number 4. L is A N B M such that N is greater than or equal to 1, M is greater than or equal to 1, and NM is greater than or equal to 3. So who did this? Okay, what's the idea?
I did it so either n can be 1 and m can be 3, or vice versa, and then
3 or greater?
3 or greater.
Yeah.
And then vice versa with the other ones, and then one where they're both 2 or greater.
Uh,
Like N and
oh,
M are 2 or greater. That's
Okay,
like
yeah, that's correct. And in fact, you only need to cover 2 only, because greater than 2, that's covered by the greater than 3, or
Yeah.
3 or greater, yeah. So
But
it's,
they're both-
so yes, you are right. So there are 3 cases. So either, n, either n is greater than or equal to 1, and m is greater than or equal to 3. This is case 1. Case 2, I did not draw the line here, so maybe some of what I was writing was not, I forgot to draw the line today, so there is always something, okay. And even this, oh, I got it right, okay, so, yes, in fact, this is not gonna be in the recording. This stuff is not going to be on the recording. Okay, so that's why you should take notes. Okay, this is this whole recording thing is an additional resource. So it's not that, don't rely on it. It's so anyway. Okay, so this is n greater than or equal to 0, m greater than or equal to 3, or the other way around. M is greater than or equal to, or let's keep n. N is the one that is greater than or equal to 3, and n is greater than or equal to 1. Or case,
M is greater.
oh, m. And case 3 is n equals 2 and m equals 2.
I gotta ask, for case 1 and case 2, wouldn't it be the case that if they were both the max possible values, which would be a 3 and a 1, wouldn't that...
That's
Oh wait,
the
no,
max,
it's
that's
A
the minimum.
times B, not... Okay. I was thinking it was A plus B. Alright.
No, you need
I got
n
it.
and m.
I got it, yeah.
Okay, n multiplied by n. So this is so these are the 3 cases. Now it's straightforward. So n is greater than or equal to 1, so that's A star, followed by B star. Okay, so this is at least 1, followed by anything. So this is at least 3, but it could be greater than 3, or A star, followed by B star. So this is 3 A's, or A B. Does this cover everything? Can you think of a string that belongs to the language and it's not covered by any of these? Yeah, so this, I think this covers everything. And in fact, you can have overlap between these two. So if you do, instead of doing AABB here, you can do A star, B star. That's fine. And then you have overlap between this and this or this. It's okay if they overlap. Okay? So this will also be correct. Question 5. So now we are given the regular expression and we need to define the language. A star, B star. So what's the language? L is the language, W such that W what?
Has a multiple of 3 followed by an odd number of B's.
Okay, it starts with
A multiple of 3A.
one person. Yeah, give me your answer. Starts with
A multiple of 3A's and then followed by a odd number of B's.
okay. So this is not the right description. It's almost correct, but I can give you a string that, according to your description, belongs to the language, but it doesn't. So you said it starts with a multiple of 3 A's, followed by an odd number of b's. So I can give you this. Then I can put anything I want. Then I can put A, B, A. I can put anything I want. When you say it starts with a multiple of 3 A's, followed by an odd number of B's, your statement is not exclusive enough, right? So you did not exclude, you failed to exclude something like this. So in order to exclude this, what should you?
Consistent.
Yeah, consists of. So W consists of a multiple of 3 A's followed by an odd number of B's. Okay? So make sure that you you word it precisely enough. And this exclusion is important to make sure that you are not allowing strings that don't belong to the language. To AB star, what's this?
Starts with the substring AB.
Starts with AB and
Followed with a pattern of substrings AB.
again, this is not exclusive. Yes.
It starts with substring AB followed by any number of the substring AB.
But again, if you say it starts with AB followed by any number, I can say AB then A. This starts with AB followed by this.
What is it?
A
Of the
substring.
substring AB, it can't be out of the AB.
But it's, if I'm an advocate of this thing, I can say that this starts with AB followed by AB, but then there is something else. So you should, yes.
W consists of the substring AB repeated at least twice.
Exactly. Yeah. That's a very precise description. Yeah. So the substring consists of the substring AB repeated at least twice, or repeated at least 2 times. So in words, L is W such that W consists of AB repeated at least 2 times. And in fact, there is a better mathematical description here than you can describe it in words like this. But sometimes, the mathematical description is even stronger. You can say mathematically, it's AB repeated n times, such that n is greater than or equal to 2. In fact, the mathematical form is much more concise, precise, clearer, and it's always the mathematical notation is more precise than English. Yeah. So both are okay here.
On quizzes and tests, do you want us to specifically put it into writing in words or mathematical, or do we have a preference between?
Like I said, both are acceptable here because this is precise enough. But I certainly prefer this. Unless the question says do it in a mathematical form or in an algebraic form as opposed to describing the language in words, both will be okay. Okay, I want to do at least one Thompson construction. We only did one. Okay. So the last two, this is, we try to be fast. Epsilon A, B. So in fact, this has a precise description. This, how many strings does this generate? It only generates 2 strings. In fact, the most precise way of describing the language, if there is a finite number of strings, is specifying these strings. And in fact, in this case, there are only 2 strings. So the most precise way of describing the language is just specifying these 2 strings. So this is the language. It's B, A, B, or B, B. This is the, yeah.
What question number is this? I can't figure
Number
out what it is.
4.
Oh, okay.
Oh, I put an A, okay. 4. Is it 4? It's 3 in fact. But you have done the homework, so you should know which question.
I don't have it memorized.
A. Okay, so what's the language? So what's this?
W consists of an odd number of A's and even.
Odd number of A's. I'm not going to write it because it's too long. So it consists of an odd number of A's followed by an even number of B's, or it contains the substring BA. Okay, to save the time, I'm not going to write this one. So I'm going to do one Thompson construction example because we only did one. Okay, so do you think I should do Thompson or subset construct? Which one is? Thompson. Well, I know that if I have time, I'm going to do both, but it's, yeah, I have only 10 minutes. So how many people want Thompson?
Subset.
Okay, 4, 5. And the subset? Okay, subset. So more people want subset, so subset. Anyways, anything that I will not cover, I'm going to post the solution. Okay, so let's do this subset construction. Oh, so now, in this case, so we have this NFA, we need to convert it into a DFA. So first step is to identify the different states. So we have either 1 by itself, or 2 by itself, or nothing, or 1, 2. By the way, there is another question in which there are 3 states. So when you have 3 states, you have to consider how many subsets? 8 subsets. So with 1, 2, 1, 2, 3, if you have 1, 2, 3, you should do 1, 2, 3, and 5, and you should also do 1, 2, 2, 3, and 1, 3, and all of them. 1, 2, 3. So when there are 3 of them, you should do all these 8. Okay, so now for this, what are the transitions for 1 on an A?
1 or 2.
On an A, you can do this as a phi. As we said in class, you can do, sorry, not, it goes to phi on an A. You can say, okay, I can take the epsilon transition and then I do an A and this will take me to 1 and then 1, 2. So if you do it A, or if you do it like this, to 1, 2, it will eventually lead to the same result. Why? Because this is going to cancel it there. Okay. But let's stick to the condition of not doing the epsilons before. So don't do the epsilons before. But even if you do the epsilons before, you're going to get this, and eventually it's not going to make a difference because this one is going to cancel. Any state that has an epsilon out of it, an epsilon transition out of it, is going to cancel at the end. But don't cancel it in the beginning, by the way. In the beginning, you should show all the steps. So show step by step. Don't jump to the final answer. But I'm just telling you that whether you do this or this for the 1, it's going to give the same final answer. So this is on A. Now what about B? The B takes us to 2. And then is there an epsilon transition out of the 2? No. So we stay there. So the key idea in the subset transition, in the subset construction, is to follow the epsilon transitions. Don't forget to follow the epsilon transitions. So this is a B. Okay, now we are done with 1. For 2, on an A, we go to 1, right? We go to 1, but then the epsilon can take us back to 2. So for 2 on an A, we get to 1. So this is a key idea. Now if you get this wrong, everything's going to be wrong. So again, let me emphasize this. The transitions from 2 on an A, you can go to 1, but since 1 has an epsilon transition, you should also count 2, because it can take you to 2. So it's very important for this to be 2 going to 1, 2. The idea. Okay, now 2 on a B, we don't have anything on a B for 2. So 2 on a B goes to 5. Now the 1, 2. Transitions for 1, 2 are the union of the transitions for the A and the B. For the 1 and the 2. So 1, 2. So it's like 1, 2 on an A is going to be 1 on an A goes to 5. 1 on an A goes to 5. And 2 on an A goes to 1, 2. So it's going to be 5 union 1, 2. And that's 1, 2. Okay? Now 1, 2 on a B, again 1 on a B goes to 2. And 2 on a B goes to 5. 2 union 5 is 2. So 1, 2 on a B goes to 2. Is everyone following? Okay. Now, are we done? Well, we have
5. What happens to 5?
First of all, 5. All 5 is going to be a trap state. Everything is going to give us 5. Okay. Now that's one thing. What else? What's the start state? The start state is the epsilon closure of the original start state. What's the epsilon closure of 1?
1, 2.
1, 2. The epsilon closure of 1 is 1, 2. So epsilon closure of 1 in this case, or let's call it Q1, is going to be Q1, Q2. Okay, so it's going to be 1, 2. So this is our start state. What are the accept states?
The 2 and also 1.
The accept states are, yes?
I just had a question. Can you explain the epsilon closure again?
Okay, the epsilon closure of a state is the state itself plus all the states that can be reached from that state using epsilon transitions.
So like
Okay.
if we have a start state at 1, you can reach 2 with an epsilon, so that's this
Yeah,
epsilon
that's
closure.
why the epsilon closure of 1 is 1 and 2. So the epsilon closure of a state is the state itself union the set of states that can be reached from that state using epsilon closures. So it's like you are doing a DFS or a BFS from that state, and you only consider the edges that are labeled by epsilon. And all the states that are reachable via epsilon closure, via epsilon transitions, belong to the epsilon closure. Okay? All right, so where are we? So this is the start state. What are the final states?
1, 2, 2, and
Okay, in this case, 1 is the original accept state. So anything that has a 1 in it is going to be an accept state. Because this is 1. So anything with a 1 in it I already put this as an O. I already, it's gone ahead. Okay. Anything with a 1 will be an accept state. Why? Because 1 here is an accept. You know, like if you have 3 states, you know, if 3 is an accept state and 1 is an accept state, then anything with a 3 or a 1 will be an accept state. So in this case, you know, this will be an accept state, this will be an accept state, this will be an accept state, this will be an accept state. So if 3 and 1 are accept states, then anything with a 3 or a 1 in it will be an accept state. Okay, so now we have, what's the final step? Simplifying it, or minimizing it, or deleting unreachable states. So deleting unreachable states, which states are unreachable? 1. So we just delete this. And we can redraw it as 1, 2 as an accept state, on an A going to 2, B returning back, on an A it remains there. Wait a minute, so, oh, it's the other way around, yes. On a B it goes to 2, and on an A it returns to 1, 2, and then on a 2, the B takes you to a trap state with an A and B. And what else? So I have 2 transitions here, I have 2 transitions, and this is the final gear. Okay? Any questions? Yes?
So like on a test for showing our work, is it okay to use like a table to do our work instead of like the states going back and forth?
That's okay, yeah. Any way of showing the work. But please show the work. And showing the work, you know, if you make a mistake, then you will get more partial credit if you show your work, then, because I will know what you are doing. But if you give me a final answer and it's wrong, I have no idea of telling what went wrong. If you show me your steps, then I can give you partial credit for the steps if your answer is wrong. So you are more likely to get partial credit if you show your work.